Good morning, this is Dr. Polaiah, working as a professor in the Department of IT, Institute of Aeronautical Engineering, Hyderabad. I'm very happy to inform you on our today ELRV topic, that is on definitions and technology, which concentrated on uh, components of an image processing system. So this is the topic which we had to understand simple definitions and terminologies for the sake of enhance the knowledge in the view of image processing. Actually, we are aware about the digital image processing, which we call simply image processing. Actually, this origins of digital image processing, where we want to define as a field. So that the field of digital image processing refers to processing digital images by means of a digital computer. So an image may be defined as a two-dimensional function we called as f of x comma y, where x and y are spatial, that is plane coordinates, and the amplitude of f at any pair of coordinates x comma y is called the intensity or gray level of the image at that point. When x and x comma y and the amplitude values of f are all fine discrete quantities, uh, which we call as finite discrete quantities, we call the image as called a digital image. I repeat, the definition of digital image is here when x comma y and the amplitude values of f are all finite discrete quantities, we call the image as a digital image. So, what is the image sensor, which we are connecting under the components of an image processing? Actually, image sensor, which we used to define in aspect of two elements, are required to acquire digital images. The first is the physical device that is sensitive to the energy radiated by the object we wish to image sensor. So that is the first in the what we had to consider in the view of physical device. Whereas the second, called a digitizer, is a device for converting the output of the physical sensing device into digital form. So this digitizer is a device for converting the output of the physical sensing device into digital formation. So simply, we also have to be aware how we may be specialized the image processing hardware, which under the components of an image processing usually consists of the digitizer mentioned before plus hardware that performs other primitive operations such as an arithmetic logic unit, which we are going to use ALU. ALU is arithmetic and logical unit which performs arithmetic and logical operation in parallel on entire images, which we are going to be called. Suppose ALU, we going to be classified into two categories. Number one, arithmetic. Number one, arithmetic. Number one, arithmetic. Arithmetic, and number two is logic. Okay, so here the logic which we are understanding, arithmetic will come. The major operations are minimum addition, subtraction, and division, and we call multiplication, etc. Whereas the logical operation which we are applying, same addition we keep in the form of AND gate, that is AND gate, sorry, not AND gate. and or not sorry not and some universal games. Excellent. So what do you mean to understand from here? So your arithmetic and logical unit operations are all will be performed in the entire image processing. Okay, so this type of hardware sometimes is also called a front end subsystems, and it is most distinguishing characteristics is speed. In other words, this unit performs functions that require fast data throughputs that the typical main computer cannot be handled. So this is one of the important. So image processing software also we want to concentrate as to define how the software tool can be defined in terms of image processing software. As we are aware about today's the software which we are going to be have multiple way, that is number one, mostly it is easy to implement your image processing in the form of either editor way or a simulation way. So we used to use MATLAB MATLAB toolbox toolbox. Here, this toolbox simply they called as a digital image processing toolbox. This processing tool. So, which they are going to be use this type of image and toolbox there. Actually, they used to concentrate for the development of or sorry, it consists of specialized modules that perform specific tasks. A well-designated package also includes the capability for the user to write code that, as a minimum, utilizes the specialized modules. Understand? So here, your specialized modules may also connect to the some other software which we are going to use as a toolbox in terms of Python also. Python tools. Okay, so these type of Python tools which they are concentrating also in terms of where we can implement even this not only Python tool software which we are writing in terms of which we are using Jupyter book, and then we are preparing the specialized modules of image processing software. So of course, based on this MATLAB toolbox and software Python toolbox, which we can use here, which in terms of consists of specialized modules that perform specific tasks, a well-designated package also includes the capability for the user to write code that, as a minimum, utilizes the specialized modules. Whereas, if you want to implement those type of softwares, we have to proceed steps by steps models. Okay. So, what are those are fundamental steps in digital image processing? Number one, image acquisition. Number two, image enhancement. Number three, image restoration. And number four, color image processing. And wavelets and multi-resolution processing. Image compression, morphology image processing, segmentation, object recognition, representation, and description. These all are based on the knowledge of the image processing. Based on the knowledge of the image processing. The knowledge which we have to have here, knowledge-based image processing may going to be acquire a image. Okay, that is input to the system. Suppose this image acquisition, which we are concentrating as we are have to aware about the acquired image, may have its some what we call enhancement needed. Then we are going to use the image enhancement tool. And suppose you are want to apply some filterings in the image, which we are called as image restoration. Image restoration there. The unwanted information in the image may remove. Best example is redundant information will be removed, and we are going to give you the original image as we are applying the image restoration. Of course, these three steps are mandatory whenever you are proceeding knowledge based image processing, and we extend that knowledge based image processing in terms of color image processing or wavelets and multi resolution processing. Those are specialized. For example, when you are concentrating about this image compression, uh, we are going to apply in terms of image restoration and image enhancement also, where a color image processing where we want to define by the help of wavelets and multi-resolution processing. So, and whereas if we want to go in detail about external this color image processing, we can also apply morphological image processing, segmentation method, object recognition, representation and description of the description of the methods which we are going to concentrate at core step. Of course, we understand that the components of an image processing system network which we are keeping in terms of so this network, how this may be concentrating on components of an image processing system, may want to concentrate to extend image displays, computer process, mass storage, hard copy, specialized image processing hardware, image processing software, and problem description, which we are going to be keeping in terms of proceed with the help of image sensors, and typically we apply this complete network process in terms of general purpose of digital image processing system. If you want to define each component of such image processing, we call as a digital image processing system components. Number one, image display. Number two, computer software process. Number three, the image which you are processing will be stored. And number four, the hardware copy which we are using, ALU process. And number four, specialized image processing hardware we used, that is either Python or MATLAB or based hardware system we can use, and we proceed as image processing toolbox, and which all connected based on the input of the image which is we are taking from the image sensors. Of course, let me define each and every component from the what we call generalized digital image processing block diagram. First one, image mass storage capability. As we are all aware about this, mass storage capability is a must in the image processing application, and the image of size 1024 into 1024 pixels, as much as megabyte of storage space if the image is not compressed. So digital storage for image processing applications falls into three principal categories. Number one, short-term storage during processing. Number two, online storage relative fast recall. And number three, actual storage characterized by infrequent access. Externally, we understand about this mass storage capability as a one method of providing short-term storage is a computer memory. Another is by specialized boards called frame buffers that store one or more images and can be accessed rapidly. The online storage method allows virtually instantaneous image view as well as scroll, vertical shifts, and pan horizontal shifts. Online storage generally takes the form of magnetic disks and optical media storage. The key factor characterized the online storage is frequent access to the storage data. Finally, actual storage is a characterized by massive storage requirements but infrequent need of access. Let us we define another component of digital image processing, which we are in the form of connecting network. That is second one is image displays. What do you mean this display? So the displays is used today are mainly color, nothing but preferably flat screen colors. We called as TV monitors. The monitor are driven by the outputs of the image and graphics displays cards that are an integral part of a computer system. Hard copy devices used for recording images include laser printers, film cameras, heat sensitive devices, inject units, and digital units such as optical and CD-ROM disks. So let us we had to see that once we understand each component, how those are connecting through network only. It is a more it is almost a default function in any computer system is used today because because of the large amount of data inherent in image processing applications that the key consideration in image transmission is bandwidth. In dedicated networks, this typically is not a problem, but communications with remote sites via the internet are not always as efficient. So let us we extend our fundamental steps which we are connecting based on the components of an image processing. We used to have some steps named as the fundamental steps in digital image processing. Let me to take one screen image which is acquired image, and this image you wanted to keep in terms of internal image plane that we called as imaging system, and that we are going to process towards to get your output. So by the help of the total steps of which we are going to follow step by step. As we discussed in the earlier slide, how this image acquisition can be called as input of an image, and that we need to be enhanced. We can use this image enhancement, and you want to remove the unwanted information, we can use image storage, or you want fit and hit the mass storage processing by using morphological processing, and where we want to segregate or keeping in terms of groups of parts of pixels for the sake of enhancement of an image. We also going to use in terms of segmentation, and also we want to keep the part of an image which we want to recognize as a object recognition. We can use here the representation and the description which we want to enhance your image. We can also sometimes the performed image which we want to transfer from one device to the another device, we used to use image compression, and here we are going to use the color image processing also in the same steps. Of course, so as we discussed about the first step, image acquisition, the meaning of it, modalities for getting the image into the computer. The image is captured by a sensor, nothing but a camera, and digitized if the output of the camera or sensor is not already in digital form using analog to digital converter. So, how many types of an image enhancement techniques is here? Input image is connected to the enhancement technique towards to get output image. That we are classified into two types. One is in the time domain, that one spatial domain technique, another one is recursive domain technique. Of course, there is a best example in aspect of understanding from Lena image, that is spatial domain, which we are keeping in the view of understandable and converted into recursive domain by using the Fourier transform for the sake of digital image processing application. With this, I want to close our discussion today, which we are understandable about this definition of terminology or components of image processing. What are the components are majorly used to define or design the great what we call digital image processing system, digital image processing system. Being it is a system which we want to keep on to the increasing or keep on to the develop, by the help of not only software tools but also hardware. So I hope you understood the complete definitions of image processing in terms of simple steps and block diagram also. I'm also encouraging you all to understand about this same concept from our prescribed textbooks. Of course, these textbooks are very useful and help us to keep on to the what we call referring further definitions. The first textbook which we are called is Richard E. Woods. This Richard E. Woods digital image processing, and second book is called Fundamentals. That is fundamental of digital image processing. Yeah, it's also very fundamentals. Of course, we wanted to refer as we discussed about the digital image processing using some softwares also. So this one they're going to use using MATLAB software. With this, I want to close today our discussion, and we'll continue further for understanding the same definition of technology with some more topics. Thank you so much. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.